to begin. It's a pleasure to be here. So why are we here talking about Microprofile? Why am I here talking about Microprofile? Well, first of all, I heard of Microprofile along with a colleague like a couple of years ago and thought like, well, this looks cool, what is this? And I looked a bit into it and thought that, yeah, it still sounds cool. Where do I go to find examples? Oh, I couldn't find a thorough example or like anyone guiding me through the entire process, like everything Microprofile is. Okay, so we thought, well, okay, let's do it ourselves then, if no one else has. And, well, of course, you can have technology, but then you need something to showcase it on. And we figured out, okay, so Microprofile, what can we use it for? At that time, our company was about to move to a new location, to a new office. And then we figured out, well, in an office, you need lights, obviously. And, well, we're an IT company, so we can use IT to control the lights. So, hey, HR, can't you allow us to control the lights in the new office? So we said, yeah, add some coffee, add some enterprise developers, and you got HR saying no. So in our office, we still have normal lights, but we figured out, okay, let's make an alternative way to do it anyways. So then we ended up by creating this architecture of our system, which we're using Microprofile on. And here you can see several services. The ones in kind of yellow are the ones we have made. Oh yeah, by the way, when I'm saying we, I've done this talk and prepared and made all things along with Rustam and Mandara, a colleague of mine who couldn't be here today, but hopefully next year. But so we made this system. The ones in yellow we already made, and the ones in gray is future work. So we have one service that gets the current weather, or like the current weather forecast, so to say. We have a service that, yeah, this is really microservices. It gets the current time. We have another one that speaks without light bulbs. That's a separate service, so that if we are to buy new light bulbs from another provider, we would just have to switch or change that one. And we got the gateway service, which has all the logic. But before we go any further, what is Microprofile? How many of you, raise your hands here, have an idea what Microprofile is? A couple of you, okay, good. Easily put, Microprofile is to microservices what Jakarta EE is for monoliths. It's not true, but it's like a nice heuristic. And it's also kind of, as well as Jakarta EE was, it's kind of a reaction to the fact that Java EE was so seldomly updated. It got a bit stale after time. And we figured out that, well, the world is moving, the technology is moving faster and faster, so we need a way to actually speed up this, so that we need to get new features out as soon as we need them, not when the slow process gets us there. And you can also say, how many use Spring Boot already? Okay, some more, yeah. So Microprofile applications can typically do all the things that Spring Boot apps can, and the other way around. But what makes Microprofile different is that Microprofile is a standard, or like a set of standards, just in the same way Jakarta EE is a set of standards, Microprofile is as well. So there is now one Microprofile implementation or reference implementation or anything like that. But as long as you adhere to these standards, you adhere to Microprofile. So that also means that there are several vendors, as we'll see in a moment, that create application servers that are Microprofile compliant. So I borrowed a few slides from the official Microprofile presentation. This is one of them, like the organizations that are supporting Microprofile one way or another. And you can see that we have all from huge corporations like Oracle, Microsoft, Hazelcast, to LGC, the London Java community, SOU Java, the Java community, I think it's in Brazil, and several other vendors as well. And some of these have their own implementations of Microprofile. This is also from the official webpage. You can see that we have application servers from IBM, the Open Liberty, from the blue one in the lower corner here, Oracle Helidon, Oracle's one. But you also have smaller ones like Cumulus EE. Cumulus is a small company from Slovenia, making a really small app server. And you have, of course, the new shiny app server, Quarkus, which almost is a microprofile implementation. And that's a bit of a detour, but we can take that short detour. Quarkus is great, and it's a microprofile compliant on everything except CDI. The Quarkus implementation of CDI, dependency injection, is not using the same implementation as everyone else. It's not using WELD, the reference implementation. It's using something called ARC. So that's a different implementation of CDI, which has not implemented everything. So technically, it's not adhering to the standard, and thus Quarkus isn't really a microprofile implementation, technically speaking. But for like regular business software, like I'm working on, I guess many of you are working on, it's perfectly good enough. Like they're covering 90-something% of CDI, including the parts that are most commonly used. So what is Microprofile then? What does it consist of? Well, it consists of what you need to create microservices, easily put. So the things you can see in the big box here are the things that are included, like Microprofile proper. And that includes things like, CDI, as I've already been speaking about, but it also includes JAX-RS for creating REST services, JSON-B and JSON-P for JSON conversion. And these are the same things that are in Jakarta EE, exactly the same standards. So like the bottom layer here and for the bottom are also present in Jakarta EE. And on the upper two lines, you can see fault tolerance, metrics, health checks. I go through each of these during the talk, no worries. And several other things that you typically need when you create microservices. And there's been made some quite conscious choices here that you can see you have JAX-RS for REST services, you don't have JAX-VS. So like Microprofile is opinionated in the sense that, we use REST, we don't use SOAP, for instance. And you also had the fun part on the right here, the standalone parts, which I'm not going to talk much about today. But lots of focus on reactive at the moment, as in the community in general. But for those of you that want to hear more about reactive, Oleg Dohuka has a talk on reactive streams later today, so go there. Okay, so let's head into what we have done with Microprofile. So in the light control service, that's a service up to the upper right corner here that speaks to the light bulbs using an SDK. Don't use the SDK, it's deprecated and it's not fun to work with. But they do provide a REST API, which is quite okay. So if you choose to go for Philips Hue light bulbs, which these are, use the REST API. Don't use the SDK. Really don't. So what have we done in this service? Well, we're using CDI. It's like, we're using CDI all over because wiring things is, the app service is better than I am. So this application scope thing, which injects the properties, just works. JAX-RS and JSON-P. It's also the same things as in Jakarta applications. It says JSON-P here on the slide. We're using JSON-B, but it supports both. I prefer JSON-B whenever not, because like JSON-B is much easier to work with. Like if you just say light state here, then it automatically converts that to using JSON-B. If you're using JSON-P, you can do much more stuff, but you have to handle more things yourself. So if you need more complex things, then that's fine, but you probably don't. But this is things that they just work. It's not that interesting to talk about, or like not in that way, but like we're using it and it works exactly the way we expected. So like if you have an experience from Jakarta EE, Java EE world, then this is the same thing. But this is all you need to create a microservice exposing a REST endpoint, these things. All right. Yeah, and that's one of the benefits, I'd say, with Microprofile, is that it's boring. And by that I mean, well, it makes it easy to create a REST service, it makes it easy to do dependency injection, it makes it easy to do all these normal things, so that you have more time, energy, and focus to spend on the hard things, the problems that you're actually solving with your application. So the gateway, this is the fun part, where all the logic is. Yeah, and here we are injecting config, and in mostly every application, you need to inject, or you have some properties, you have some URIs, or some endpoints, or some passwords, or secrets, or usernames, or anything that you need to get into your application. If you want to have, like, you say the same Docker image all the way from development to test to production, then you need one way to get these things into your code, so that, yeah, obviously don't use production endpoints in test and so on. And in Microprofile, you have the standard called config, which is what you see here. And this annotation takes, like, it reads, if you run java-jar and then -d something, it reads that. Or if you use properties in a properties file, it can read that. Or if you put some properties in your Docker file, it can read that. And if it finds none of these, it can use the default value. It also uses system properties. And there's an order here, so that, well, if the same value is defined both as a default value and as a Docker value, then it prefers the Docker value. And there's this current discussion going on in the Jakarta EE world, that whether this should be part of Jakarta as well. Like, my initial thought is yes, it should. You typically need it in any application. You need these things that are different. So we're using this for light bulbs. We're using these config properties to say, well, what should the default value be for the color? Well, blue or green. All right, health check. Who are using Kubernetes? A couple. Okay, in Kubernetes, you have the concept of liveness probe and readiness probe, which says whether your service is running or not, and whether it's ready to accept traffic or not. And that can be exposed as to different endpoints, typically as. And with Microprofile, you can implement that. Like, the result you get from those endpoints look like we see on the screen, JSON. Not really intended for human reading. You can read it, it's not that complicated, but it's like, yeah, whatever. But you can put it into Kubernetes. And all the things you have to do that is you add some applications, so not applications, annotations. So here you can see this one has @liveness. And then you can see that it implements the health check interface, and it overrides the call method. And this is all you need to do to create a liveness probe suitable method inside a Microprofile application. Yeah, and the same with readiness. And you can see the URI at the bottom here. It's like /health/ready. And here we just use random.next boolean. Don't do that in production. But for testing purposes, it's fun to see if it's sometimes up, sometimes down. So, yeah, we're moving quickly through some of these. So we're heading on to metrics. And metrics, well, by default, you get a lot of metrics, availability endpoint /metrics, and that gives you things like how much memory are in use, how hard do we run the CPU, how many threads are running. There's like page up and page down of different default metrics you get out of the box. And these follow the same format as Prometheus does. So if you're using Prometheus and Grafana, the most usual combination of metric scraping and visualization, it plugs perfectly fine into that. And it's fine with like the default general purpose metrics, but you can also do some more fun because you typically have something you want to measure yourself with your own application specific metrics, which you can do. You have a separate page that lists the application metrics. So on this one, we just made a one. Okay, how many times have we tried to change the light bulbs, or like to change the lighting color and strength and so on? And that exposes it as a separate metric. And to do this, we just added an annotation to the method you want to expose here. So that's a single specific annotation. Oh, yeah. So, fun and big topic, fault tolerance. Like one of the things with microservices is that something's going to fail, definitely going to fail, and what do you do then? You should think of that. And here's one of our REST endpoints. As I said in the beginning, we do a call to our weather forecast service so that we get the weather forecast. Because like if the weather is raining and storming and really bad, then we want the light bulbs to switch to another color or another strength. Whereas if it's sun outside and like so bright that we don't need any light at all, we should handle that. And here you can see that we are using a couple of techniques for fault tolerance. So we say retry, max retry is 2. You can specify how many times you want to retry. Default is 3, I think. So if you just write retry, it tries 3 times. And it also has, this is kind of fascinating, circuit breaker. And the circuit breaker works kind of like the circuit breaker in your house. So like if you hammer this method lots of times when the service is down, then you won't DDoS yourself. So it will handle that in a proper way. But there's more to fault tolerance. There's also timeout. Sometimes there are methods that can take a long time if they do go further. Of course, this depends, of course, on your application and use case and all of that, but it might be useful sometimes. And you can freely combine this, so you can use retry and timeout and circuit breaker, combine them as you want. Yeah, and you can also use config, combine this with config so that you can set this from outside if you, for some reason, want to do that. Yeah, and if everything else fails, okay, go to a fallback method. And this is one of the methods I've struggled the most with, because it seems really simple. But if you happen to if the fallback method has a different signature than this method, then you're screwed. Or then you get an exception that just tells you close to nothing. So I didn't understand anything for a long time until I suddenly realized that, oh, it has a different signature. Then I guess it doesn't work. And I fixed that, and boom, it worked. So that's a heads up on that. So, as I said, Microprofile is a set of standards. And I'm going through lots of standards today, but you can pick and choose freely. One you typically need in many contexts is a REST client. It's like your service speaks to another service through REST, which you can do being pretty close to Java. Actually, this is Java, but it's an endpoint behind it. And you can see there's some magic here, or at least some things you haven't seen before, probably. The registered REST client annotation says that this endpoint actually is a REST endpoint somewhere. This interface hides a REST endpoint somewhere. So these are the REST endpoints on the light control service, and this interface is from the gateway service. And when you're using it, you inject it and annotate it with @REST client, and then everything hopefully works. Especially if you do some magic in the properties file. This is feels like black magic, but in your properties file, you have to specify that, okay, this endpoint actually points to this address. And once you got this working, it's awesome. If something isn't working, I didn't find it that easy to understand why. But there is a pattern here behind. So it's important to get the property file address right, which you hopefully do if you Google it. So enough like running through features, but a bit about Microprofile in general. I call this one maturity, and by that I mean it's still a young technology. Like Microprofile started 2 years or so ago. It's now on version 3.2, so it has evolved quite quickly. But in that you also see that not everything is maybe as stable or as mature as you could expect it to be. So like we had experience where we started out in using one app server, and we figured out that, oh, this one doesn't really support REST client yet. Okay, but this one does, so let's switch. So we had a lot of those kind of issues. And we're also, I said Microprofile 3.2 is out. Microprofile 3.1 came 2 weeks ago. And usually there are new versions like 3 or 4 times a year. So why this short period behind 3.1 and 3.2? Well, that's because 3.1 was a mistake. In Microprofile, one follows the semantic versioning, so that like breaking changes typically only happens in the major versions, so 1.0, 2.0, 3.0, and so on. But in Microprofile 3.1, suddenly it turned out that, whoa, we're not backwards compatible. There's a change in the metrics implementation that, the metric specification that breaks everything. Well, not everything, but like that's a breaking change from 3.0. So we had to roll back that. So the new version 3.2 is actually just a rollback of the metrics from 3.1. And that's a typical sign that, yeah, development is going fast and things are happening, but sometimes it's happening too fast or without the right appropriate level of control. So you have to be a bit aware that, well, things might happen. All right. So a final few points on specifications. And the time and weather services are quite simple. So we use CDI, we use JAX-RS and JSONB here as well. But we also use OpenAPI. OpenAPI looks like this if you expose it like in text form. And this is like specification of your endpoints. Typically you push this one into Swagger UI or API EE or something, or some tool that reads this format. But you can see what you get here is like you get a summary, what the endpoint does, and some description, and a list of the responses you can get. So it actually describes your API. And all you do to add this is the single line here with at operation. And you can plug this one into typically Swagger UI. So like OpenAPI is a standard, but the implementation that mainly everyone is using is Swagger. And that's a bit of like underlying ID, so to say, of the entire Microprofile is that we take the typical implementations or the typical standards and we put them together, package them together. So that's the presentation for now. Let's head on to the demo. And for the demo part, I'm going to show you the most beautiful view front end you have ever seen. No, I don't, but so we created a simple front end, which has 2 buttons, reset lights. That's just so when you came in here, you can see that the light bulbs were quite dimmed. If we didn't have the reset light, then you would be sore in your eyes by now. But all the functionality, like all the 4 services we just been speaking about, is hidden behind this set lights this set lights button. So when I push that button, hopefully the light bulbs will switch light strength and color. And that's the live demo. So if we try this, you can see there's a lot of things going on. There we are. And you can see that, well, on the screen here we list like how strong are the light bulbs. And we added a bit of randomness just for the sake of demo. So if I do it again, you can see it. We get some new colors. Or new strengths, sorry. And you can see that the light bulb, this one, is not green as the other 2 are. That's because that's just a grayscale light bulb. No other reason than that. And this is all our system does. So it's a bit no open engineering. And you can see that those two green light bulbs get green, and that's because we said if we get the feedback from the weather service, then we use the green color. If we don't get any feedback from that, if that fails, then we use blue color. And then we base it on the current time of day. So that's quite simple in that sense. So we can have some fun and look at some of the output. Can you see this, or should I switch colors? It's fine, okay. And you can see we have 3 services running. So the front end, yeah, just plain simple Vue starter app. I really like Vue, by the way, but that's another talk. Okay, and we can see that we can actually see what happens when I push the button. Hopefully. Okay, set lights. You can see we get a lot of output. Yeah, a lot of services. So, okay, so the setup is like in this tab here, we have the running the time service, the weather service, and the light control service. Because neither of ours are that good in Docker, we created the gateway outside of Docker. So like, okay, so what we do is that we, okay, this is kind of lots of magic. Okay, not good for demo as such, but what this set button does, it accesses an endpoint, which is at localhost 9080. That's the gateway /u, I think. Yeah. I think that's right. Okay, now I try to reset them, and we do that again just for fun. Yeah. Okay, so this is the actual endpoint, and this is in the gateway. So the gateway then heads on to the weather service and tries to get, okay, so what's the current weather in Stockholm? Just a random place. Stockholm, Sweden, and in Stockholm the forecast said, oh, it's supposed to be 7 degrees Celsius. Okay, and then we say, okay, that means that you should have brightness of 168. So the brightness is between 0 and 255. And because of the randomness, it says 168. And yeah, and then we go and, well, actually speak to the light bulbs. So the facade is here, blah, blah, blah. New brightness, yeah. So there we set the brightness on the light bulbs to 197 on this one, and 184 on this one, and so on. So there's a lot of things here you wouldn't do in production, but you know. Okay, so we still have, I think I still have 7 minutes left. That's kind of cool. I can show you some other fun things. As I said, Microprofile is a standard. So if you use Microprofile, yeah. So if you use Microprofile, as in the weather service, we are using Thorntail. It's an app server from Red Hat. The ones it's deprecated now. You should use Quarkus instead if you're starting now. But we started when it wasn't deprecated, so we used Thorntail. But if you use Thorntail and want to switch to another app server, for instance, Cumulus EE, all you have to do is, you don't have to change the Java code at all. Like you see, but okay, so the Java code is here. It's exactly the same code between those two services, between those two app server versions. So we only changed the POM file. The POM file and the Docker file. That's all the things you have to change to switch between those two app servers. Unless you have some strange property files and so on, but for a simple application like this, that's the only thing you actually do. Yeah, there's like specific dependencies and so on. Yeah. So no, I don't think we have time to live show that, but yeah, if we build it, the way I built it so far is I've been using Maven clean install, so we can do like if we cd into the weather service, like what I've done for the regular building. So if I just use plain Maven clean install, so we use the regular POM file which uses Thorntail, but if we add -p -f cumulus, and it builds with cumulus and runs perfectly fine. But that's for another time where time is running. So, okay, let me try to summarize some of the things we learned during this work. New cool things keep on coming. I mentioned Quarkus, like my favorite app server so far. I have to admit that. Like I have no connection to Red Hat, but like I like Quarkus. And also Microprofile Starter. So this is like Spring Initializer, but for Microprofile, so to say. So if you want to get started using Microprofile, this is a great place to start. If you Google Microprofile Starter, you get to this landing page, and you can say, okay, this is my group ID. This is so. I think it actually has support for Gradle now as well, but it started out with Maven. So you define like group ID, artifact ID, choose which version you want and which app server you want. And like, if you want some examples, okay, how is health checks done? Okay, if you check this button, then you get some examples in your code, in the code base. So that's a very easy, quick way to get started. Yeah, not going to spend too much time on this, but we started out using Lombok. Lombok generates a lot of boilerplate code for you, but it also adds complexity to your application. And we figured out that, well, we had a talk at a conference a while ago, where 1 hour before the talk, nothing was working. Like, everything was broken. And we figured out, okay, what is this? What's wrong? Like, we got like strange compilation errors. Google told us nothing. Like, oops, what do we do now? So we tried, okay, let's remove everything we don't know what works. So like, let's try to remove Lombok, see what happens. Well, exactly the same thing happened. But like, okay, so Lombok wasn't the issue, but it was a potential issue. So it might be nice, but you might probably not need it, or maybe not need it. Yeah, it turned out to be an error in the app server in Thorntail with the new Maven version in the end. Yeah, same thing. We started out with some fancy tricks with loggers and injection. Like you can inject loggers with @inject using CDI if you do some magic like this. But we figured out, well, we only need some prints to system out. I like to get it out from the containers anyway. And like, okay, so let's do it a better way. So some over-engineering as well. So we wrapped system out print line in an application scope bean because we could. More than good enough. Like, not complex at all. Yeah, another thing we learned is that app servers differ. And what do we mean by that? Well, for instance, open tracing, I haven't been talking about that yet, but open tracing is a specification in Microprofile. In several of the app servers, it is implemented using Jaeger, and in others, it's implemented using Zipkin, like two different tools. That's clearly a difference. Another difference we clearly see is that how long is the time between a new Microprofile version is released and an actual implementation of the version is released. Varies a lot between the app servers. So at the moment, several are on 3.0 or 3.1, and several others on 2.2, 2.1. So it varies a bit on that as well. All right, SmallRye. I don't really have that much time to talk about SmallRye, I think, but SmallRye is an implementation of just Microprofile, so that you can plug that into your app server. Your app server, for those of you creating app servers. It's an initiative from Red Hat. It's used under the hood in Thorntail and in Quarkus for most saints, and also partly now in OpenLiberty. So I don't know if it's going to like spread out to the rest of the app servers. Still a bit early to say. Other cool tech stuff. Okay, so I try to sum up now. Local Maven repo. Yeah, if you got an SDK or a jar file from anywhere that's not in Maven Central or in any Maven repo, you can make your own. Might need it. Yeah. If you do program against light bulbs or physical things, do create fake versions so that you don't have to bring your light bulbs everywhere to program against it. So like, just fake an implementation of the API. Docker is cool, Docker Compose is cool, we're using that. future work. Okay, I gotta sum up now. So we're using 3.0. 3.2, the specification just came out. So we're using 3.0. When 3.2 comes, we're gonna adapt to that, of course. Open tracing, haven't used that yet. JVT authentication and propagation for security. Haven't done that yet because of time and space. Yeah, 3.2 just came, as I told you. Kubernetes is cool, OpenShift is cool, we should run it on that. Yeah. And Istio. Nicola talked about Istio earlier today, I guess, so I wouldn't have to repeat too much on that, but for many reasons, Istio is cool. Okay, so the entire project and all the code, not the light bulbs themselves, but all the code is on GitHub, on the upper link here. And both me and my colleague Rustam has written a bit about Microprofile because of what we learned during this talk. So that's the two links in the middle here. And to the bottom, we also add a link to Rick Peel. That's Philip Rick. He has written a great deal of documentation on every part of Microprofile, available at that link. And of course, the official webpage is microprofile.io. There's a lot of great info there. And then I say thank you for your attention.